Ozone O3, each oxygen atom has 6 valence electrons. Therefore, the total number of electrons will be equal to 6 plus 6 plus 6, which is equal to 18 electrons. You can show 3 oxygen atoms and each oxygen atom has 6 valence electrons around it. 2 of the oxygen atoms can get 8 electrons around them by mutual sharing of a pair of electrons between them. That is, each oxygen atom contributes 2 electrons for sharing with the other oxygen atom. Thus, 4 electrons are shared, so a double bond will be formed between those 2 oxygen atoms. The third oxygen atom requires 2 more electrons. So, the oxygen atom at the center will contribute a pair of electrons for sharing with the other oxygen atom. Thus, a single bond will be formed between those 2 oxygen atoms. You can see that certain electrons are not involved in bonding. Those are shown separately. When you take the total number of electrons around each oxygen, you will get it as 8. The electrons which are not involved in bonding are known as lone pair of electrons. So, we have both bond pairs of electrons and lone. Lewis representation of carbon monoxide, CO. Carbon has 4 valence electrons and oxygen has 6 valence electrons. Thus, we get a total of 10 valence electrons. So, start with carbon, oxygen. Oxygen has 6 valence electrons and carbon has 4 valence electrons. Now, consider oxygen. It has 6 valence electrons around it and it requires 2 more electrons to get the octet configuration or 8 electrons around it. So, carbon will contribute 2 electrons for sharing with oxygen. Both the electrons come from carbon. A single bond is thus formed between carbon and oxygen. All the 6 electrons of oxygen remains as 6 electrons around oxygen. Carbon has a pair of electrons not involved in bonding. Now consider oxygen. After bond formation, it gets 2, 4, 6, 8 electrons around it. But what about carbon? It has only 4 electrons, 2 plus 2. So, carbon should also get 8 electrons around it. So, what will happen? Oxygen will donate or contribute 2 pairs of electrons for sharing with carbon. A pair of electron is now shared with carbon, so a single bond will be formed. Another pair of electron is also contributed by oxygen for sharing with carbon, so another bond is formed between carbon and oxygen. Thus, we get a triple bond between carbon and oxygen. A pair of electrons not involved in bonding, it remains as a pair of electrons with carbon. Similarly, in the case of oxygen, 2 electrons or a pair of electrons are not involved in bonding. It remains as a pair of electrons with oxygen. Thus, a triple bond is formed between carbon and oxygen. Both carbon and oxygen has a pair of electrons not involved in bonding. 8 electrons around carbon and oxygen. We have studied the Lewis representation of simple molecules like chlorine, nitrogen, water, ethene, ethyne. Thus, we have learned that Lewis dot structures help us to know the bonding in molecules in terms of the shared pair of electrons and the octet rule. So, let us now learn the Lewis representation of anions like carbonate, nitrate, nitrite and cations like ammonium ion. Lewis representation of anions and cations. Here we will be discussing the representation of anions like carbonate, nitrite and nitrate and cations like ammonium ion NH4+. But there are certain rules to be followed. So let us have a quick look into the various rules to be followed. For anion, if the anion carry one negative charge, add one electron along with the total number of valence electrons. And for cation, and if the cation has one positive charge, then subtract one electron from the total number of valence electrons present. The least electronegative atom should be shown at the center, so it will occupy the central position. Account the shared pairs of electrons for single bonds. You know that a single bond is formed when a pair of electron is shared between 2 atoms. So shared pairs of electrons means that can be taken as a single bond formed between two atoms. Remaining electron pairs after the formation of single bonds, if electron pairs are remaining, then those electrons can be used either for multiple bonds. Multiple bonds means either double or triple bonds, or those electron pairs remain as lone pair. So remaining electron pairs will go either as multiple bonds or it will remain as lone pairs of electrons. Each bonded atom gets an octet of electrons. After bond formation, when you count the total number of electrons around each atom, we should get it as 8. So each bonded atom should get an octet of electrons. So these are the rules to be followed.